Are you hearing Isabel, right?
I am from the Environmental Technology Verification Body. So,
Are you hearing her?
Yeah.
Okay,
so
okay, let me restart.
hello, good morning. Hello, good morning, everybody. My name is Izabela Ratman-Kłosińska. I am from the Environmental Technology Verification Body from the Institute for Ecology of Industrial Areas in Katowice. Today, I would like to present to you a little bit on the framework that we're going to use for the assessment, verification, and the validation of the PCP Teresa solutions with dedicated focus on the technical verification approach that we're going to use. I apologize that I cannot be with you today in person. This is due to the traveling. Nevertheless, I hope that the information I will provide today will give you an understanding on how we are going to approach the assessment of the PCP solutions at the individual procurement stages. So the technical verification approach actually establishes the conditions for which we're going to evaluate the solutions in the different PCP stages. Here, I would like to highlight that for the PCP phase 2 and 3, we'll be using a standardized approach, which is described in the ICO 14034 Environmental Technology Verification Standard that I will present to you in this presentation. And that will allow us to provide objective evidence for the whole consortium to verify that the prototypes that are being designed in phase 1 actually meet the desired technical and functional as well as environmental performance requirements. So the Teresa PCP includes 3 phases: the solution design, the prototype development, and the original development of a limited volume of first products. And for each of these phases, we have defined specific timelines, the TRL levels, including enter TRL level and expected exit TRL level, the scope, the objectives, and of course the testing environment and the related requirements. I will present them in the next slides. Let's begin with PCP phase 1. The duration assumed for this phase is 3 months. The objective is to assess the technical, economic, and organizational feasibility of the innovative solutions and to select the most robust designs for phase 2, which is the prototyping phase. What we will expect here is a complete system architecture and its design, including any documentation like blueprints, presenting the components, the processes, the algorithms, expected environmental impacts of the system. It will be also important to have a defined monitoring and measurement concept presented, including the operational parameters, which of course will be technology specific depending on what kinds of unit processes you are going to involve in the system. The monitoring for the effluent quality, the quality of wastewater for reuse, if you're assuming that in your system, and of course the monitoring of the removal of the Teresa PCP target contaminants, which is critical to define the actual performance of your system. So the solutions here will be evaluated on their ability to credibly progress to the prototyping stage and the feasibility to meet the Teresa PCP KPIs, about which I'll tell at the end of my presentation. At this stage, we're not expecting any testing. However, it would be beneficial to have any test data to substantiate the feasibility of the system design to deliver the claimed performance. The expected exit TRL level is 5 to 6, which means that the technology components have to be integrated with realistic support elements. So the complete system design is feasible to perform to meet the key performance indicators. Concerning PCP phase 2, the expected duration for this phase is 10 months. The objective here is to develop and experimentally validate the functional prototypes and to demonstrate the measurable technical performance under controlled conditions. We are expecting here the prototypes development based on the phase one designs, of course, including also the monitoring concept, and the performance to be tested against a verification plan, testing protocols based on the agreed KPIs framework, and criteria including quality assessment and quality control that refers especially to the testing requirements. The prototypes, the solutions will be evaluated in particular on their performance, technical, functional, environmental, and performance, and the interaction with the realistic conditions and operational environment at the hospitals. Here we'll have already the testing phase. The prototype, it will include prototype laboratory testing of performance based on those test plans and KPIs and quality assurance and control systems. The testing will be performed at the premises of SAS, in particular Hospital Virgen de la Macarena in Spain. The testing will be performed as indicated in control simulated conditions. However, they have to be representative to the PCP Teresa Hospital conditions. We'll also assess here the potential for the integration with the operational environment of the hospitals. The expected exit TRL level is 6 to 7, which means that the prototype system demonstrated in an operationally relevant environment. For the PCP phase 2, again, the duration assumed is 10 months. And the objective here is to validate the final solutions in real hospital environments in order to verify their declared performance, their robustness, and to confirm their readiness for the deployment. The scope includes real-world testing under diverse hospital-specific conditions to verify the performance claims related, of course, to the technical, functional, and environmental performance following the ICO 14034 ETV process. Also to prove the environmental, economic, and social added value of those solutions, and also to demonstrate the full integration capability with the environmental, with the operational environment of the hospitals, including the system control and the monitoring. So here the solutions, which will be no longer prototypes, but pilots in their final form, which means we're talking here about complete systems, will be tested and validated under defined conditions of application to check their actual achievement of the declared technical, functional, and environmental performance. And that will be done based on a factual approach using independently produced test data under real conditions of application, and also to check if they meet the end user needs in terms of economic, social, and integration with the operational environment. Here we'll have, again, a testing phase. The testing will be based on the deployment and the validation of two most promising solutions in 4 hospitals. You have those hospitals listed on the slides. So there will be hospital in Spain, in Netherlands, in Estonia, and in Poland. At this stage, all the systems must be integrated in the real-world operational environments of the hospitals. The performance verification will be based on technology-specific verification plans and test plans that will be integrated with the KPIs. All the test data must be generated under restrictive quality assurance and control rules compliant to ICO 17025 standard, which basically means that accredited laboratories will need to be involved at that stage. And of course, they will need to be related to the on-site conditions of the hospitals in which the testings will be done. Then we'll use the third-party verification under ICO 14034 ETV standard to confirm the performance claims. The exit TRL for this stage is 7 to 8, which means that the pilot system is demonstrated in a real-world environment. Now, let me explain why we're using this ETV scheme in Teresa PCP. ETV is a scheme that consists in proving in an impartial and credible way that the claims that are made by the technology providers about performance of innovative environmental technologies are true and are based on sound scientific data. The verification under ICO 14034 ETV has some specific features that make this scheme especially appropriate for innovative technologies. First of all, the approach is standardized by an ICO standard. It is robust and transparent, and it's technology neutral. This is a standard that is from the group of environmental management standards. And because it has been approved by ICO, and this is also a European standard, it is recognized in the EU and globally. The second feature of ETV is the quality and the impartiality that is assured by the process. The whole verification scheme is based actually on two well-recognized quality assurance and compliance standards. First of all, it requires that the test data that are used for the verification are generated under the conditions of ICO 17025 standard. This is a standard that you may know because it refers to the laboratories and their work. And the second thing is that the verifications are performed by verification bodies like ours at the Institute for Ecology of Industrial Areas that need to be accredited to ICO standard 17020. This is a standard for inspection bodies. And we are accredited under the most restrictive rules of impartiality, which means accreditation for type A inspection bodies that allows us to ensure full impartiality of the professional judgments that we're making. And third, very important feature is the fact that ETV is fit for early market innovations, which is the case for Teresa PCP, because it allows to verify what is most important about the performance of a technology to demonstrate its innovation towards the buyers and towards the users. Unlike compliance schemes, ETV is flexible in terms of the choice of performance parameters to be verified. So these could be adjusted, for example, to our KPIs. And it also enables proving the performance claims of technologies that cannot be verified in any other way because there are no existing regulations or standards or different labeling schemes that could reflect this performance. And this is also the case for Teresa PCP because we do not have a standards right now for the removal of the target contaminants that are in the focus on Teresa PCP. So to summarize why ETV in the Teresa PCP is that, first of all, the scheme defines at the level of an international standard on what is an environmental technology, which means technology that results in a less adverse or positive impact on the environment compared to solutions to which it is an alternative. ETV also defines the term of the environmental added value, which is an indicator if a technology really results in this reduced impacts, and it also regulates that at a standard level. Moreover, ETV allows to verify new, even disruptive technologies, and this is what we're expecting here under this pre-commercial procurement, that could demonstrate unique technical, functional, environmental performance. And this is because of the rule of this flexibility. Uh, Fourth, ETV defines a process for technology performance claims verification and the claimed environmental benefits that allows also to verify the assessment of the technology maturity. So that refers to the TRL level. It's innovation, proving its innovation, considering also all the assumptions and constraints and limitations that are related to the technology application and its scalability, which is again the case for Teresa PCP. Uh, it also ensures that all these assessments are being done with adequate quality, credibility, and impartiality, which builds trust for the users of this information, and in particular the buyers, the clients, but also for the regulatory purposes. The central elements of ETV are the performance claims, which are, technically speaking, a set of technical specifications that represents the functional, technical, and environmental performance of the technology that are defined for specified application and under specified conditions of testing or use. That will be also the case for Teresa PCP because we'll be testing the technologies under specified conditions of the hospitals. And of course, test data on the performance that needs to be collected that will be done throughout phase 2 and phase 3 with the purpose of phase 3 to deliver data that can be independently verified following the requirements of ICO 14034 standard. How do we envisage the implementation of the ETV scheme in the Teresa PCP? Again, this is not fixed yet. Nevertheless, I wanted just to highlight with this slide what benefits and what elements of the system might be integrated into PCP phase 2 and 3. First of all, for PCP phase 2, we'll look into establishing a common background for the definition of the intended application of the technology on the basis for the assessment of the environmental added value, and that means the environmental identification of the key environmental impacts of the technology. Also, the common approach for the definition of the initial performance claim, and it's, of course, alignment with the user's needs. We'll be also using this approach to provide guidance and to get from you a clear understanding on the technology constraints and limitations, because this is extremely relevant for the future technology users to get a clear understanding if this technology will work in their operational environments. And of course, something that is subject to the verification, this is the specification of the performance parameters that are to be verified. We'll also try to build common testing requirements with the quality assurance behind them so that the test data generated through the process can be easily compared. Concerning PCP phase 3, here we'll already implement the full ETV process. That will mean that the definition of the intended application will need to follow the requirements of the ICO 14034 standards. So it will need to be expressed in terms of matrix characteristics, matrix meaning the material for which the technology is intended for. In our case, this is the hospital wastewater. We'll need to clearly define the purpose of the technology, basically speaking, what actually the technology is doing and how it is affecting the parameters of the matrix, and all the assumptions and limitations under which the technology can be implemented. We'll also make here the assessment of the environmental added value based on the available data. This could be also data that Luna will be talking in a moment in her presentations, referring to the sustainability aspects. The definition of the final performance claim and the specification of the performance parameters to be verified, because this will be technology specific depending on what actually the technology is intended to do with the hospital wastewater. And we will here follow the testing requirements according to ICO 14034. That will mean that the testing will need to be done by independent test bodies that are able to demonstrate compliance to 17025 requirements, and the verification of the performance will be then based on the test data produced in that way. That means that for the PCP Teresa phase 2, we will prepare common verification protocols and testing protocols that would allow to make the benchmarking against the KPIs. For PCP Teresa phase 3, for each of the verified two technologies, because there will be two technologies actually in that phase, maximum two technologies, we'll develop technology-specific verification protocols that will include the test design. And based on that, the test plans and the test reports will need to be generated by independent test bodies and provided to us while the test data is available. And for each technology, at the end, we'll generate a verification report and a statement of verification stating the actually achieved performance parameters of interest. I have been talking throughout this presentation about the KPIs. The key performance indicators are a part of the operational validation framework for the project. They are still under discussion. They need to be also confirmed by the buyers group. Nevertheless, we have come out already with an idea and directions into which those KPIs could go based on the analysis of the commercially available technologies, the state of the art, the innovative technologies that are under the pilot stages right now, and also the baseline conditions and expectations of the hospitals, the buyers group. So you can imagine that we'll be looking into KPIs that would refer to the technical and functional performance, focusing, of course, on the target pollutants to be removed by the PCP Teresa. Of course, something that would be related to the effluent quality parameters, the treatment capacity, the robustness of the technology under the different influent loads, and also the expected peaks of the flows and the content of the target contaminants, although we do not have this information yet. And also aspects related to reliability, the down frequency, and very important, the scalability and the modularity of the solutions versus their technical and functional performance. Of course, since we're talking about environmental technologies, for sure, we'll look into any KPIs that will be related to environmental performance and the sustainability. As said before, my colleague Luna will deep dive a little bit more on the sustainability aspects. Nevertheless, I don't want to spoiler her presentation. Nevertheless, you may expect issues related to energy consumption, water consumption, chemicals consumption, waste, noise, hazardous waste, other nuisance, this type of aspects. Operational KPIs that will be related to the constraints and limitations and needs of the hospitals. First of all, related to the size of the installation, the footprint, how easily this installation can be operated, what are the maintenance requirements, what is the automation level, so that it requires minimum effort for running, the monitoring capacity, and also the safety considerations for the staff. Costs are highly relevant, so for sure there will be some KPIs on the costs, on the regulatory and compliance. We'll also think about some KPIs because the whatever technology will be delivered here, it has to comply both with the regulatory requirements that are site specific. So especially that there might be some requirements from the hospitals and also from the wastewater um, operators on the installations themselves, and other aspects that are related to the discharge limits, for example. You may also expect some KPIs that will be related to the quality assurance of the whole systems, especially on the test data that will be needed for the verification. I think this is all from my side. I guess this gave you an understanding about our approach. Thank you very much.
Okay, so that was from Isabella. So maybe now, Luna, do
Yeah.
you want me to share?
Yes, please. Can you share?
Okay. Okay, let me 1 second. Okay, tell me if you can see the presentation.
Yes, this is not my presentation. Sorry.
About this.
Yeah, it is.
Yes.
I don't know what's wrong with my camera. I can't seem to turn it on, but it's okay. I'm just gonna go ahead. Hi, I'm Luna. I am a project officer at Healthcare Without Harm Europe. Bear with me, I'm a bit sick today, so if you want me to raise my voice or repeat something that was unclear, please let me know. You feel free to interrupt me. And I will be asking some questions during the slides, so feel free to use the chat to reflect on anything you want. So, as Isabella had already highlighted, I'm going to be talking about the sustainability assessment. What is this based on? It's based on life cycle thinking aligned with the ISO 14040 and 14044 principles. These are the LSA standards, if you're familiar with them. And we're going to rely on evidence from peer-reviewed LSA and LCC, which is life costing and social sustainability literature on hospital wastewater treatment, which I have to say is quite limited in literature right now. There are some emerging harmonization efforts for these kind of assessments, some peer-reviewed articles, some recent compilation of existing articles as well. And we're going to rely on the hospital inputs. However, I would like to highlight that what I will present, there has not been any final agreement made yet. These will be in another phase, which is the evaluation design, will be co-developed with hospitals and will be finalized in the next phase. Next slide, please. So baseline conditions at the pilot hospital, I am sure you've seen this before if you attended other meetings, but the common baseline is that the predominant routing is discharged to municipal sewers. Some hospitals do have existing stream-specific controls, like high-risk streams managed separately, or some sites reporting screenings and filters. What is the implication for suppliers? I would like to make it clear that most of the social environmental impacts that will be assessed in the sustainability assessment will arise only when the site units are introduced. And as Isabella had also mentioned, solutions must fit the hospital realities. Next slide, please. So this is a list of an environmental dimensions to consider. As I said, they are still being discussed and they're not final, but just to give you an idea, first we have the energy used, which is a strong driver of climate emission and cost as well. Climate relevance, resource and material use. I saw in the previous presentation a link to also circularity, so that could make sense here as well. So using materials that are durable, water efficiency, water recovery potential, the ability to recover or reuse water, chemical and reagent use, waste sludge generation, formation of hazardous byproducts. This could sometimes be unintentionally done through wastewater treatment processes. And finally, ecotoxicity relevance. I know this is hard to quantify. I've been reading a lot of articles on this, and I see that there are still a lot of gaps in literature on how to do this properly, but we would like to explore it as well. I would also like to highlight that we are aware of trade-offs, so higher removal performance can come with higher energy or chemical or material burdens, and this assessment is meant to help compare these transparently, and I will talk about this a bit later on as well. Next slide. So from the literature, we know that energy use is actually the dominant life cycle hotspot in advanced hospital wastewater treatment. Across LSAs, this was consistently identified as the largest hotspot, especially in treatments like oxidations, UEVs, AOPs, which is advanced oxidized processes, and membrane systems. Pilot hospitals also in Teresa project also identified energy efficiency as a sustainability priority, and it's worth noting that some of these sites operate or plan to expand on on-site renewables like solar energy. And my question here is, do you have insights on what is the minimum energy intensity solutions can achieve in this high removal performance? So based on literature, what I found was low energy was in between, 0.5 or less. Moderate energy was between 0.5 and 1, and high energy was over 1. So we are looking to go towards more the low energy, but I would like to hear some of the opinions and reflections on this. Thank you. Next slide. Social sustainability, what is this about? It's mainly about safe, acceptable, low burden operation, social evaluations in healthcare hospital wastewater treatments are limited. Indicators are often qualitative and very context specific. So what are we looking at here? Worker safety and training needs. We want to make sure that workers are aware of all the safety procedures, and we also want to make sure that the workload and operational complexity remains feasible for hospitals. We know a lot that hospitals cannot take on more workload. Social acceptability in hospital settings, so this relates to the noise, odor, footprint, and siting constraints. It relates to the operational KPIs. Public health contribution, the reduced release of ARBs and ARGs and hazardous residues can be framed as an expected contribution, not as epidemiological proof, but the reduction of AMR in general could be a public health contribution. Responsible business conduct and human rights due diligence, so these are supply chain expectations, of course, that we expect suppliers to have. And finally, something that's a bit exploratory but worth mentioning in social sustainability is gender and inclusion, so inclusion in design and training as well. Next slide, please. Finally, we have the economic affordability, something that Isabella also highlighted. So costs vary widely, we are aware of that, but affordability is one of the feasibility gates for this project. How do we approach it? We have the CAPEX, which is the upfront investment in treatment equipment and installation, and the OPEX, which is the costs that come with electricity, routine maintenance, and so on. What are some of the economic drivers that are mainly present in literature? We found that energy demand, consumables and media replacement, and maintenance and staffing time, and finally, high-cost components can dominate in specific wastewater treatment technologies that are presented, like ozone generation equipment. So all of these drive the economic cost within the treatment. Next slide, please. So based on some of the literature, I will not go through this in detail, but I found some studies from Denmark, which are quite old, but they use UV disinfection and it has shown really low OPEX. There's not a lot on CAPEX, which is the upfront investment, but there's more literature on OPEX, which is what comes later in the prices. Meanwhile, you can see here up to one is the power activated carbon and membrane bioreactor, which consumes more electricity probably, and it's a mixed type of solution, so it's not only one. And it can go up to 2.5. This was a case study in Italy of submerged membrane bioreactor and ultrafiltration. So costs go up depending on how much there is combinations or what kind of electricity demand they need. And I'm just asking if this looks realistic. You can also share your thoughts. Thanks. Next slide, please. So what we're trying to do here is that we are aware of all these trade-offs, and what helps us guide our assessments is a benefit burden thinking. So we will look at both the added value, as Isabella mentioned, in terms of environmental added value, and what are the benefits socially, economically, but also the burdens. And we can see in the assessment later on how this will be balanced. We know we are aware of some trade-offs like transformation products, unintended byproducts, or high removal performance leading to higher energy burdens. But all of this will be taken into consideration. And I ask again the questions, what are the biggest trade-offs that you foresee? Next, please. I think this is my final slide. No. Yeah, this was my final slide. Thank you very much. And
Yes,
feel
yes,
free
it
to
was.
leave anything in the chat and reflections. Thank you.
Okay, perfect. So for the final part of the technical aspects is Diana, do you want me to share?
Yes, please.
Okay,
Thank you very much.
perfect.
So meanwhile, I introduce myself. So my name is Diana Cortés, and I'm manager at Silo, a Spanish consultancy based in Madrid, specialized in innovation procurement. For the Teresa project, we are responsible for the exploitation and adoption strategy. So thank you, Bartos. So first, I would like to briefly explain how exploitation and adoption are addressed within the Teresa project, with a particular focus on the intellectual property rights under the pre-commercial procurement. You know, this is the approach we are having in this project. So for the PCP model, is built around a key principle, which is risk and benefit sharing under market conditions. So this means that both public procurers and suppliers share the risk and benefits related to research and development activities, especially when it comes to intellectual property rights. In practical terms, this approach provides both protection and incentives for suppliers. So project beneficiaries retain the intellectual property rights they generate while ensuring access to any necessary background knowledge for other participants involved in this PCP project. On the other hand, PCP providers also retain ownership of the results they develop. In return, the buyers group is granted several important rights. The first one is a royalty-free license to use the results for their own internal purposes. And the second one is the right to request or to grant themselves non-exclusive licenses to exploit the results under fair and reasonable conditions. There is also a public interest safeguard known as callback right. This mechanism will only be applied if exceptional circumstances, for example, if the results are used against the public interest or if they are not commercially exploited within the agreed time frame. In such cases, a following consultation would be done with the PCP providers. The procurers may require the transfer of the intellectual property rights ownership. Overall, this framework is designed to stimulate innovation, provide legal certainty for suppliers, and ensure that publicly funded R&D leads to tangible and reasonable market outcomes. So moving to the next slide, please. I will also outline how this IPR framework is supported by a structured exploitation and adoption strategy in the case of the Teresa project. So the overall objective is to develop a comprehensive action plan that supports the final adoption of the solutions. This plan combines tailored strategies both for procurers and suppliers with the aim of ensuring successful exploitation and long-term sustainability. For suppliers in particular, which is the focus of this webinar, the strategy is organized on 3 main phases. So the first phase is the early engagement and orientation, which will start from January 2027. This phase includes webinars focused on business modeling, funding opportunities, and go-to-market strategies. The aim of these webinars is to support suppliers early on in understanding the commercial potential of their solutions. The second phase, the validation and tailor support, which will start in January 2028 and go onwards. During phase 2 of the project, individual follow-up sessions will be provided. These sessions will help suppliers refine their exploitation plans, strengthen their business models, and prepare funding application. The third and last phase is the consolidation and market adoption from April 2029 onwards. In this final phase, the focus will be on consolidating business strategies, facilitating access to funding, and ensuring readiness for commercialization and market uptake. Through this step-by-step approach, the Teresa project aims not only to develop innovative solutions, but also to ensure that they are successfully adopted and create real impact in the management of hospital wastewater. So